up, what up? Welcome to Mr. Brown's class, where there's no whining and no complaining. Today we're talking about simplifying radical expressions. Alright, and we get to look at my favorite word in all of math, alright, radical. Alright, so we're talking about square roots. Alright, and here's the property, the product property. So product means multiplication. Okay, so product property of radicals. And that means that the square root of A times the square root of B equals the square root of A times B. So let's look at this. So if we have the square root of 3, right, times the square root of 6, that equals the square root of 3 times 6, or the square root of 18. Okay? And if we do it the opposite, the square root of 18, which is the square root of 6 times 3, is the same as the square root of 6 times the square root of 3. All right? And you'll see this as we go through, because we're going to use prime factorization, all right, to simplify these radical expressions. Now, some of these are perfect squares, all right, and some of them are not. And so we'll see that as we work them out. So let's work at taking this, right, and we're going to use the prime factorization tree. All right, so 5 can go into 225 because it ends in a 5, right? And so it would go into it 45 times. Right? And then this is a prime number, so we're going to circle it. Okay? 45 can be 5 and 9. 5's a prime number. And 9 is 3 and 3. Okay, now, here is the key. Alright, so if you have a pair, think about it this way. 5 times 5 is 25, right? So the square root, so let's rewrite this as 5 times 5 is 25. Right, 3 times 3 is 9. And like up here, okay, that's the same as the square root of 25 times the square root of 9. What's the square root of 25? 5. Square root of 9 is 3. So the answer is 15. Now, we could have also just looked at this, right? And if we have a pair, it just counts as 1. So this counts as 1, 5. And this counts as 1, 3, right? And we multiply them together, 5 times 3, okay? So because, and again, square root, because 5 times 5 is 25. All right, let's try this one. 9 times 8, 72, right? 9 is 3 and 3, right? 8 is 2 and 4. These are prime numbers, so we can circle them. Right? 4 is 2 and 2. Okay, now, remember that a pair, right, a pair counts as only 1. Right? So we have a pair of 3s, right, and a pair of 2s, and then we have one extra 2. Right? So what happens is that the pairs go on the outside of the radical, and what's left over stays on the inside. So this would be 6 times the square root of 2. And again, we can look at it this way. All right, 3 squared is 9, so that's 9. 2 squared is 4. All right, and then we have this extra 2. 9's a perfect square, which is 3. 4 is a perfect square, which is 2. and then we have this extra 2 on the inside. All right, why don't you try to do this one on your own? Go ahead and pause it. Okay, well, we know we can divide it by 10 because it ends in a 0. All right, so 10 can be broken down into 2 and 5, which are prime numbers. And 32 can be broken down into 2 and 16. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. All right, now we're looking for pairs. All right, so we have no other 5. Okay, so here's a pair of 2's. All right, so remember, that goes on the outside of the radical, so that counts as 1, 2. We have another pair of 2's. It counts as 1, 2 on the outside of the radical. And then we have another pair of 2's. All right, so 2 times 2 times 2 is 8. And we have just this 5 left over, so that stays on the inside of the radical. Whatever's not a pair stays on the inside of the radical. So 8 times the square root of 5. All right, try the square root of 180. All right, so again, it ends in 0, so we can do 18 and 10. All right, 2 and 9, 3 and 3, and 2 and 5. Okay, so let's look at for pairs. So we have a pair of 3's. We have a pair of 2's. And again, we have a 5 left over. So that goes on the inside of the radical. So 6 times the square root of 5. Okay? Now remember that imperfect squares, if we put these into our calculator, remember these are irrational numbers. So they're going to go on forever and never repeat. So we simplify them as far as we possibly can go. Last one, pause it and figure this one out. Okay, so we have 9 and 10, 3 and 3, 2 and 5. We have a pair of 3's. Okay, now we have no other 2 and we have no other 5. So we're going to multiply those together, and that's our answer. So if you're left with 2 lone numbers or 3 lone numbers, multiply those together, and that stays on the inside of the radical. Okay, now we have variables involved. So let's first focus on the square root of the number. Okay, now most of you know what the square root of 81 is, or should, but let's look at it from the way that we've been doing it. Okay, so we know it's 9 times 9, all right, 3 times 3, 3 times 3. That's how we have a pair of 3's, all right, 3 times 3 is 9, so 9 goes on the outside. Now, this, if we broke down x to the 4th, right, that would be x times x times x times x. Now we have a pair of x and a pair of x's. Alright, so what do we have? X times x, which is x squared. Alright, now if we take y to the 3rd, we have y times y times y. And we only have one pair of y's, so that counts as one y, and the leftover y ends up on the inside. Now you're going to figure out a pattern here. Okay, so if it's an even number, all of them are going to go outside, and it's going to be half of the exponent. Right? If it's an odd number, you know that you're going to have one left over on the inside, and always one left over on the inside. Okay, so pause it and see if you can do this one on your own. Okay, so 162, we know that 2 can go into it. So we'll do 81. And then we know 9 times 9. All right, so we have a pair. We could just stop right there. Okay, we have a pair of 9s. So that counts as 1 9. And we have a 2 left over on the inside. All right, now let's look at the R's. We have 4 R's. So this counts as 1 R. This counts as 1 R. So we have R squared. Okay, half of the R's. Okay. And so S's, so the pattern would be, if we wrote out 8 S's, we'd have 4 pairs of S's. And that would be your answer. Okay? If this video helped you, make sure that you subscribe and like below. And remember, be more awesome.